Hi everyone, how's it going? My name is Kunal Batra, and I'll be talking about security and specifically our well-architected framework here at AWS. Uh, so just a little bit about me to calibrate any of the questions or conversations that might happen during this presentation. I am a senior developer advocate here at AWS, essentially just an engineer who helps build awareness and adoption of our services. I've worked on a lot of different developer-focused verticals. If you have any questions on any of those, feel free to let me know. And it's just a hobby of mine. I love machine learning. I love computer vision. So help build an app that lets you know whether the garage door is open or closed, or another one for object detection and the number of people lined at the Shake Shack in Madison Square Park. So if you have any questions on anything you hear today or any of this, feel free to reach out to me. My Twitter, Kunal732, and my email, kbatra@amazon.com. Let's get started. So the agenda today, we're going to be giving a little history on our well-architected framework here at AWS. And then from there, we're going to dive into the 5 different components of the security pillar for the well-architected framework listed right below that first bullet point over there. So just before we begin, if you want to learn more about the well-architected framework after this, feel free to visit any of these links. I think next time I'm going to have a QR code here. So instead of you having to copy and paste this or wait for the presentation, you can just point your camera here. Just thought of this on the fly, but yeah, definitely next time we'll put that code there. Okay, so are you well architected? So the well-architected framework that we have here at AWS helps you understand the pros and cons of any decision you might make while building on AWS. It helps showcase architectural best practices for designing reliable, secure, and cost-effective systems. It also helps you consistently measure your architecture against best practices and identify areas for improvement. So the pillars you see here on this slide come from years of experience of talking with and architecting solutions for our customers. So a little history here. The well-architected framework was actually established all the way back in 2012. So we revised the framework every year through a process where we collect data about what worked for customers, what could be improved to provide clarity, and what should be added or removed. Interestingly, the first 3 years of the well-architected framework, these were purely for internal releases. This is not something that was public. So this was used by our SAs, our professional service consultants, our enterprise support teams to have conversations with customers about building and operating the best cloud architectures. It wasn't until 2015 where we took this knowledge and we made it public and started publishing white papers for this. And then ever since then, you can see that we keep on releasing every year updates to the well-architected framework. Okay, so again, the framework provides a way for our customers to consistently measure their architectures against best practices and identify areas for improvement, giving you guys the ability to build and deploy faster, lower and mitigate risks, make informed decisions, and learn AWS best practices. Now, in specifically the security pillar, there are 7 design principles and 5 components of this, right? So let me just go over the design principles right now. The first, implementing a strong identity foundation. So this is just highlighting the idea of implementing with the principle of least privilege and enforce separation of duties. The next principle here, enable traceability, the ability to monitor, alert, and audit actions and changes to your environment in real time. Apply security at all layers. The idea here is to think about different aspects of your application. Edge of network, load balancing, every instance and compute service, the operating system, application, and code. Next, automating security best practices. So this includes creating secure architectures that are defined and managed as code in version control templates. The next is self-explanatory, protect data in transit at rest. Essentially, basically what we're trying to do is keep people, for the next one, keeping people away from data, essentially use mechanisms and tools to reduce or eliminate the need for direct access or manual processing of data. And the last one here, preparing for security events, basically be ready by having an incident management and investigation policy and processes for when any sort of event occurs here. So those were our design principles. And now these are the components that we're going to be going through for the rest of our presentation as part of the security pillar here. So you have identity access management, detection, infra protection, data protection, and incident response. So we're going to now go through these for the presentation over here. So basically, you can see all the tools that we have that align to each of these components of the security pillar. So going to that first one, identity and access management. Essentially, this is a key part of a security program and ensures that only authorized and authenticated users and components are able to access your resources and in the manner that you intended. So there are two types of identities that you need to manage when approaching operating securely with AWS workloads. You have your human identities. So basically, these are the admins, developers, operators, and consumers of your app, which require identity to access your AWS environments. And then you have the machine identities. So these are your workload applications, operational tools, and components that require an identity to make requests to AWS services. For example, to read data, these identities include machines running in your AWS environment, such as EC2 instances or Lambda functions. You can also manage machine identities for external parties who need access. And in this slide over here, the first thing that you can see here is how a policy statement looks like in that block over there. You can have more than one policy per statement. So you see in this case, we're saying allow, and the action is list object and get object. And then we're going to say for there that will be allowed on a specific resource. You can also add wildcards to these actions as well. And you can see the resources that this will apply to. Now you can do the same thing again for your roles, for your compute instances or your Lambda functions as well. The next component here are our detective controls. Detection enables you to identify potential security misconfiguration, threat, or unexpected behavior. On that link over here in the bottom, there's just a lab over there that you can access if you want to play around and learn more. But basically, there are different types of detection mechanisms. You can have logs for your workloads, which can be analyzed for exploits. You can establish a set of detection mechanisms at the account level. And now with CloudTrail, this provides an event history of your AWS account activity, including actions taken through the management console, the SDKs, command line tools, and other AWS services. You can use GuardDuty, which is a threat detection service that continuously monitors for malicious activity and unauthorized behavior to protect your AWS accounts and workloads. You can also take advantage of AWS config, which will let you create rules that you can monitor against, as well as use to automate the remediation of any undesired configuration. And then you can take advantage of our RDK, which helps you deploy custom AWS config rules at scale across multiple AWS accounts and regions. Next, we have the Security Hub. So Security Hub is a single place that you can go to and see how you can improve your security and compliance posture. The way this works, you turn it on, and then it starts aggregating results from GuardDuty, Inspector, Macy, also integrated with 29 different partner solutions that will push their findings in an automated way. All of these services are being pushed in a standardized format from multiple sources. This provides insight, which are the most important findings and resources that need to be addressed immediately. Also, you can set up an automated response or remediation actions on specific findings via CloudWatch events. So basically the way that works is you set up AWS Security Hub in the management console by clicking Enable Security Hub and then adding the AWS accounts that you want to monitor. This then starts the process of ingesting that data across the AWS security services to Security Hub, where you can see aggregated findings and then take actions on those. Now, you can also see how compliant you are for the Center for Information Security Standards as well through Security Hub. You can see different checks that it'll do over here to compare against best practices. Now, another one of those tools we have for detection is GuardDuty. Now, GuardDuty is a pretty interesting service. There's no architectural or performance impacts when you just turn it on. Basically, you just click, turn it on. You get continuous monitoring of your AWS accounts and workloads. It's global coverage, but the results are kept regionally. So you can aggregate all your results for everything that happens and put them in S3, or you can store that into a third-party solution like Splunk, as an example. And then you get security benefits as well. Basically, you can compare actions happening in your account to known threats, intelligence that your account has access to, or unknown threats. And this is behavioral based. It takes advantage of machine learning to figure that out. So a couple of different data sources that GuardDuty takes advantage of. It looks at your VPC flow logs, your DNS and CloudTrail events as well. It does all of the heavy lifting. You don't have to do anything for logging. Data is not stored in GuardDuty. It is pulled from internal sources inside of AWS, analyzed in memory, and then discarded. It only stores the results from the findings that are produced, so your data remains your data. You can see how this works over here. It's going to ingest the VPC flow logs, DNS logs, CloudTrail events. From there, it's going to look at different types of threat intelligence. So you can see threat intelligence is something that it can access from AWS or from other partners and see what activity is happening over there. Or it can take a look using machine learning and based on a baseline that it creates of account behavior in your account, see if anything is anomalous over there and alert you to that. From there, you can see those findings and you can store that in the S3. You can also look at that in Security Hub. You can also look at that through CloudWatch events and use that to remediate as on any behavior as well. And we'll talk about that in a second. So basically, you can detect known threats and produce instant findings. The intel comes from a couple of different places for known threats. You have AWS Security Intel, which is our intel feed that GuardDuty has access to. You also have third-party vendors, CrowdStrike and Proofpoint, that GuardDuty has access to as well. This is at no extra cost to you. You can also provide GuardDuty threat intelligence based on intel that you have or you have from your customers, and this is only yours. This won't be shared with any other account. Now, you also have the ability, again, for unknown threats, taking advantage of machine learning, so unusual ports, unusual API activity, unusual logins. Basically, when you enable GuardDuty threat findings, basically enable GuardDuty to find unusual behavior, it starts a baseline of monitoring your account for 14 days. And then from there, it'll tell you when something's anomalous. So the one thing to note is when you do start enabling this functionality, don't do any behavior that's unusual in those 14 days because then it won't report against that as anomalous. Now, there are different threat detection classes it looks against, right? So you have reconnaissance. This is pre-compromised account, basically any activity suggesting that reconnaissance is being done by an attacker, for example, port scanning, unusual patterns of failed login attempts, user permission activity, trying to figure out what your permissions are. Then you have instances that are compromised, so you'll see behaviors such as denial of service attacks, outbound Tor traffic, and then you have account compromise. So now this is activity that's learned after a baseline is learned looking for any sort of unusual behavior. Now, when we create findings, we put them under different threat purpose classes, and these are all the different classifications of threats that we see. or some of the classifications. So you can consume all of these things in your console, right? So on the right-hand side, you can see all the details of the finding itself, the hyperlinks that can point you back to the resources. You can also see the count to aggregate all of the alerts of that type. So this is a way to reduce that noise instead of constantly screaming. Oh, excuse me. So you can see the aggregate for all those accounts of that type. So it's a way of reducing that noise instead of constantly having screaming alerts at you. We send you the first, and then by default, wait 6 hours before sending you again. But you can customize this down to whatever you need. You can also create auto archive filters for suppressing a particular finding based on a certain set of criteria as well. You can consume this data as well through an API with JSON too. And most of the time we see our customers consume this data alerts through CloudWatch events, which is essentially an event bus which will send them onto other services like Lambda to take a certain action. And again, these events are usually aggregated as well. So you can see an example over here. You have GuardDuty. From there, it's going to go to CloudWatch events. And then from CloudWatch events, it's going to trigger, you can trigger an AWS Lambda function to remediate some sort of action. And we'll walk through an example in just a couple of minutes here. So you have Lambda, which again, you can use to run code without worrying about infrastructure. You have Systems Manager, lets you take action and get info from an instance. You have Inspector to see if an instance needs to be updated. And you can see an example of this right here. You have the GuardDuty findings that's being fed into CloudWatch events. This is going to a Lambda function. A Lambda function can call a partner solution, do an automated response, or just notify you or anything else. So an example here, let's say you have a web application sitting behind a web application firewall. You're getting ports scanned on HTTP or HTTPS by a malicious IP. When GuardDuty sees this happening from a known bad actor, it will create a finding, which will then go ahead and trigger a Lambda function, which will add that to an IP block list in your AWS web application firewall, which prevent that actor from getting any more communication. So you can see how you can use GuardDuty to start automating security for your system. Okay, so we spoke about two services here. We spoke about GuardDuty is a threat detection service that continuously monitors for malicious activity and unauthorized behavior. And then we spoke about Security Hub, where you have that single place that aggregates and organizes and prioritizes your findings from multiple different AWS services, GuardDuty, Inspector, Macy, as well as other partner solutions. Now with Amazon Detective, it simplifies that process of investigating security findings. It analyzes all of the events from multiple data sources, so VPC flow logs, CloudShare logs, GuardDuty findings, and creates a graph model that provides you with a single interactive view of your resources, right? So essentially, it's trying to show you how everything is connected. And then in Detective or in Security Hub, when you see a certain instance or certain issue, you can click on that and it'll use Detective to show you here are all the related services for this specific issue, which will help you debug that. So this Detective processes terabytes of event data about IP traffic, management operations, malicious or unauthorized activity. Again, it organizes all of that data into a graph model that summarizes all of those different relationships in your account. And then you can go ahead and query that model and create visualizations as well and see how everything is interconnected whenever a certain issue does happen. Okay, so now we're going to incident response. Now, when you're preparing for security events, preparing for security events is aligned to incident response. So more accurately, your customers should be well prepared to deal with incidents before they occur. So you can take advantage of game days where you can play out common security scenarios. And then from there, see how you interact with those different types of scenarios, right? So you can use GuardDuty plus playbooks, and the combination of with these game days will let you sleep more, because now not only can you see what's happening, you also have playbooks that let you know, and game days where you're prepared to take action when these do happen. So playbooks provide a rough guidance of what to do in certain scenarios, which is different from runbooks, which are like a really rigid, predefined set of actions. You can see an example of a playbook here in Markdown. It's pretty basic. Running a game day, this is actually a lot of fun to do in your organizations. If you haven't, just schedule time, have prizes, provide food, create playbooks, and and learn from this. And this will also, again, let you sleep more when eventually something that undesired does happen. Okay, infrastructure protection. This is a key part of an information security program. It ensures that systems and services with your workload are protected against unintended, unauthorized access and any potential vulnerabilities. Again, you can take advantage of an Amazon web application firewall. If not familiar, web application firewall is just an application layer used to protect web assets from various forms of attack. You can think of it as a server plugin or filter that applies a set of rules to HTTP traffic. Another way to look at it, a web security service providing protection by monitoring HTTP requests and restricting access to web applications. You can see some more info here: filtering with custom rules, blocking malicious requests, and actively monitoring and tuning. All right, so now we have data protection. So before architecting any workload, basically any foundational practice that influences security should be in place. So in AWS, there's a number of different approaches you can use when addressing data protection, data classification, protecting data at rest, protecting data at transit. You can evaluate your data using tools such as Amazon Macie that uses ML to automatically discover, classify, and protect sensitive data in AWS. Macie recognizes PII, personally identified information, intellectual property, and provides you with dashboards, alerts that can give you visibility into how this is being accessed or moved. So different ways to keep people away from data. First, eliminate the data completely or limit access to it. Do you actually need to store it? Who specifically needs access to that data? You want to make sure that you have a principle of least privilege in your workloads. Next, you want to start thinking about tokenization. Allows you to define tokens to represent an otherwise sensitive piece of information. For example, tokens are used to represent a customer's credit card. Tokens are meaningless on their own and can't be derived from the data it is tokenizing. Encryption is another key here. It's a way of transforming content in a manner that makes it unreadable without a security key necessary to decrypt that content back into plain text. So both tokenization and encryption can be used to secure and protect information as appropriate. Data isolation as well. You can use different AWS accounts to store different classes of data. And you can also take advantage of tooling to help eliminate direct access. So for example, we have Systems Manager here. You can use that instead of SSH. And then finally, operations as code. So you can commit infrastructure as code to stay consistent and not introduce any new errors. Another service here, AWS KMS helps you manage encryption keys and integrates with multiple services. It also helps define encryption approach that includes storage, rotation, and access control of keys. You can also take advantage of our well-architected tool in the management console as well. So just define your workload and answer a set of questions based on the pillars. The tool then provides a plan on how to architect for the cloud using established best practices. So again, I want to learn more, you can go to any one of these links over here. We have labs for you to play around, learn more in as well. And then if there are any questions, feel free to email me, kbatra@amazon.com, or follow me on Twitter and at Kunal732. Twitter, by the way, is the fastest way to get a response from me. Thank you.